You know what? Let me send you back to the wait screen and I'm going to get the front door. I'm sorry. I'm back. Sorry. My kid just got home. So, welcome. And sorry about the confusion and the delay. I had to get my ducks in a row, and there's a lot to catch up on. There's a lot going on, and there has been a delay, not a delay, but an absence. I was gone last week because I wasn't feeling well, so sorry for that. But here we are. This is SpaceWeek, episode 132 on this Sunday, September 25th, 2022. So if we rewind the clock a couple of weeks to 2 weeks ago, on September 12th, Blue Origin launched their New Shepard NS-3 suborbital booster with the RSS-HG Wells capsule on top, containing a payload of research experiments. No humans this time, fortunately. First, let's check out the launch.
T-minus 16, guidance internal. T-minus 10, 9, 8, 7, 6, 5, 4. Command engine start. 2, 1.
Mission control confirms New Shepard has cleared the tower and is headed to space.
So everything looked good and normal until around max Q, 1 minute into the flight. If we fast forward a little bit.
BE-3 engine throttled up as we're going to push up to max Q. Again, that's the point where the aerodynamic stress on the vehicle is at its maximum. throttle back, and then continue on up to space.
So there was a critical failure in or near the booster's BE-3 engine, causing an uncontrolled spout of flame which knocked the rocket off its trajectory. The capsule's solid-fueled launch escape system engaged automatically, carrying the capsule up and away from the booster. Now, this was interesting that an uncrewed mission had a launch escape system, but the capsule is designed to accommodate either uncrewed payloads or humans. And so the same launch escape system is available and activated in either circumstance. Unlike SpaceX's Dragon 2 spacecraft, which has two different variants, the cargo variant, which does not have a launch escape system, and then the crew variant, the Crew Dragon, which has the Super Draco thrusters, which act as a launch escape system. So we did not get to see what happened to the booster, but it still had a lot of fuel in it because it was quite a ways from MECO, and it was ascending at an angle it was not designed for. It very likely exploded in midair, or at least if it survived the descent, definitely blew up when it impacted the ground because it still contained a lot of fuel. The capsule, on the other hand, was safe and sound. The parachutes deployed, and it touched down normally with a burst of cushioning retrothrust, which we will see in a moment. Poof. And again, if you haven't heard it, the many times it's been said before, that puff of dust is not evidence of a cratered landing. It's evidence of the retrothrusters which cushion the landing at the last second. Again, the New Shepard crew capsule has carried quite a number of humans, including 80 and 90-year-old elderly folks such as William Shatner and Wally Funk. So yes, the capsule landing is supposed to look like that, and it behaved normally, which was actually very impressive. It did exactly what it was supposed to do. So let's take another look at the mishap at 25% speed. So we see, now normally the hydrogen fuel burns very cleanly, and so we don't normally see this bright yellow flame. And that blast you see there, if we back up a bit, boom, that blast you see there is not the rocket exploding, or not the booster exploding, I should say, but it is the booster being enveloped in the thrust from the capsule's launch escape system, which engaged. So there we have the rocket tilting at an angle, and then there the launch escape system engages. And it uses solid propellant for the launch escape system. Now, Crew Dragon uses hypergolic fuels. They use hydrazine, nitrogen tetroxide, and hydrazine, or UDMH, which is, those are quite toxic and they are liquid, whereas the New Shepard's launch escape system uses solid fuel, rather like the SLS rockets. But in any case, now Blue Origin only has one New Shepard booster, NS4, the same booster that has launched all of their crewed flights, whereas NS3, the booster that was just lost, has only launched research payloads to suborbit. They still have both of their crew capsules, though, the RSS First Step, which is the one configured for crew, and the RSS HG Wells, which is this one that landed intact here. Then on September 13th, a Long March 7A launched Zhongxing 1E from Wenchang. On Thursday the 15th, Electron launched the Strix-1 synthetic aperture radar satellite for Synspective, a Japanese Earth imaging company, in a mission called The Owl Spreads Its Wings.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Can't really tell if the cows down there were perturbed or not, but I did see them moving around. Let's see. They got some great views of the Earth during this ascent. That down there is where they launched from. You can see the tip of the peninsula on the North Island of New Zealand, the Mahia Peninsula.
We use water to absorb the immense sound energy produced by those 9 Rutherford engines at liftoff.
Then on the 17th, 2 Shenzhou 14 taikonauts, Kai Shuje and Chen Dong, conducted a spacewalk outside the Chinese space station. And here is a view of the ingress back into the CSS. Sped up a little bit. Then last week, let's see. On Sunday, SpaceX launched more Starlink satellites from Cape Canaveral.
15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of Starlink 4-34. Go Falcon 9. Stage 1 chamber pressure.
Beautiful launch, and here is the booster landing.
Stage 1 landing burn.
Stage 1 has lit its one engine to prepare for our landing on drone ship. Just read the instructions.
Stage 1 landing leg deploy. Tico. Stage 1 landing confirmed.
Falcon 9 has landed, marking the 135th
Nominal
landing
orbit insertion.
of a Falcon 9.
And on Tuesday, a Long March 2D launched the Yunhai 103 satellite from Jiuquan Satellite Launch Center. Clean launch there. Then last Wednesday, NASA conducted a cryogenic fuel tank fill test of the Artemis 1 SLS rocket. Now, Artemis 1 was supposed to take off on August 29th and then again on September, 3rd, something like that. So the first time they scrubbed because of, well, they did detect a fuel leak, but the reason for the scrub the first time was because there was a temperature problem with one of the engines, which they were unable to resolve in time for their launch window that day. And then during the second attempt on September 3rd, I think, the problem was a persistent hydrogen fuel leak. Now, hydrogen is a tricky fuel because hydrogen is the arguably the smallest molecule in existence. Hydrogen is, of course, atomic number of 1, and a hydrogen molecule is smaller than any other molecule unless you consider helium, which, yeah. But in any case, hydrogen leaks out of basically everything because it's a tiny, tiny molecule. And so there are acceptable levels of hydrogen leakage from any coupling or valve, etc. So the quick disconnect valve that attaches from the mobile launch platform to the side of the SLS rocket to fuel the rocket with hydrogen fuel had a leak in it that was leaking at an unacceptable level. And so the second launch attempt was scrubbed. Fast forward a few weeks, and they still had not rolled the rocket back to the vehicle assembly building. It was still on the pad, and they were attempting to fix the issue in situ. Because the leak was not on the part of the rocket. The leak was in the quick disconnect mechanism from the mobile launch tower, and so last Wednesday, NASA did an extensive a many hours long test of their fueling process and systems. And so they took what they called a kinder, gentler approach. NASA likes to use a lot of sort of older phrases, and the kinder, gentler is harkens back to the Bush 1 presidential era of like 1990. But in any case, yes, they tried to take a kinder, gentler approach to their fuel fill process this time. And so they fueled at a slower rate, putting less pressure, less stress on the system. And they still had a leak to contend with. However, they were able to because they had swapped out like the seals around the valve and everything. They had done everything they could without actually bringing the whole stack back into the VAB, which would be hugely disruptive and cause many weeks of additional delay. But the good news is they did eventually bring the leak down to an acceptable level, and they were able to 100% fill the rocket both with the first and the second stages with hydrogen and oxygen. Oxygen being a much larger molecule, it's not nearly as leaky, so the oxygen wasn't problematic. But in any case, they were able to get past the hydrogen leak issue. However, so their target date for the launch, first it was the 23rd, and then it was the 27th, which would be this Tuesday. However, now we have Tropical Storm Ian potentially becoming Hurricane Ian, which is about to bear down on Florida. And as a cautionary measure, they are evaluating very carefully whether they want to roll SLS back into the VAB to protect it during the storm. Now, as of the time of this broadcast at 4:36 p.m. Eastern Time, so far as I'm aware, that decision has not yet been made. I think it will be made later this evening. But they want to make sure that if they do roll it back into the VAB for its own protection, that they do so with enough time to spare that in a couple of days when Ian arrives, the Kennedy Space Center staff will have, sufficient time to take care of their own affairs, to protect their families and whatnot. So it hasn't rolled back yet, but it might, and that decision will be made again this evening. If it is rolled back to the VAB, then there will be probably more weeks of delay before the next launch opportunity. If it is not rolled back, then it could possibly launch as early as next Sunday, but I wouldn't count those chickens quite yet. So we'll have to keep our eye on the schedule, and I'm not actually going to mention next Sunday's launch opportunity in my calendar portion of this show because we're not sure yet. But let's just say maybe next Sunday, but probably not for a while for Artemis 1. But hey, at least they got their fuel issue kind of under control. I mean, it's still leaky, but it's not so leaky that they were unable to fill the rocket with fuel. So, moving on. That same day, while the Artemis 1 fuel test was being conducted, a Russian Soyuz rocket with the Soyuz MS-22 launched 3 more crew to the ISS. Cosmonauts Sergei Prokopyev, Dmitry Petelin, and NASA astronaut Frank Rubio.
The second umbilical has retracted. This will initiate the auto sequence start. T-minus 10 seconds and counting. We have engine start.
Umbilical tower separation.
Turbo pumps coming up to flight speed.
Turbo pumps, flight speed,
and liftoff. A sunset start to the mission of Rubio, Prokopyev, and Petelin to the International Space Station.
10 seconds, flight is nominal.
Good first stage performance reported from the blockhouse at Baikonur, the Soyuz delivering 930,000 pounds of thrust from its 4 boosters and single engine.
Beautiful launch as always from Soyuz. Maybe a little rough on the astronauts, but a very capable vehicle in any case. And here's the approach to the ISS, sped up a bit for pacing.
Standing by for hover in the cone message. Range 215, range rate negative decimal 15.
A great view of the Soyuz MS-22 flying 258 miles over Morocco, moving from southwest to northeast.
Confirmed.
Docking scheduled about 16 minutes from now.
Copy. Activate illumination for the Bruce. Bruce illumination is activated for the VSK.
I thought the view of the Soyuz at a distance with the spooky Soyuz at a distance with the Earth in the background was more interesting than the actual docking contact, but there you go. There was live coverage for the hatch opening, but somewhere up here, there we go, there's a coast. In any case, there was live coverage of the hatch opening, but we didn't actually get to see it because the video signal from the ISS wasn't available at that time. Yesterday, ULA launched a mighty Delta IV Heavy rocket from Vandenberg Space Force Base in California for the last time. There are still more Delta IV Heavies scheduled to launch from Florida, at least a couple, but that's it for California. Future NRO launches by ULA will be done with the Vulcan rocket, which is expected to launch for the first time later this year or early next year, if Blue Origin can provide the BE-4 engines for it, engines which have already been delayed by at least 3 years.
Roll for ignition. 10. Test for start.
T-minus 10, 9, 8, 7, 6, 5, 4. We have ignition. 2, 1,
Liftoff.
and liftoff of the last West Coast United Launch
Engine
Alliance
cooling water
Delta
on.
IV Heavy rocket carrying NROL-91 for the National Reconnaissance Office.
So, a couple things of note, if we rewind this to the launch, the fireball that engulfs the base of the Delta IV rocket is a very famous feature of the Delta IV launches, and it's intentional, expected, and the rocket is designed to withstand that. And the reason is because the rocket uses hydrogen as a fuel, kind of like the New Shepard that there was a problem with, as well as the SLS rocket uses hydrogen, and the space shuttle used hydrogen as well. And hydrogen, being a leaky gas, does, well, leak. Additionally, they start flowing the hydrogen before the launch, and so there's an accumulation of hydrogen at the base of the rocket, or I should say before ignition. And so there's an accumulation of hydrogen gas at the base of the rocket. So when ignition takes place, that excess hydrogen burns off. And because hydrogen is a very light gas, it's the lightest gas, it ascends up the rocket. And so you get that fireball that rolls up the side of the rocket dramatically. But it's totally designed to accommodate that. And here is an excellent photo of the launch that was shared by ULA on Twitter with the iconic Vandenberg marine layer fog in the background and the hills in the foreground. I love that shot. Also yesterday, excuse me. Also yesterday, a Kuaizhou 1A vehicle-launched rocket lifted off from the Taiyuan Satellite Launch Center with the Xi'an 14 and 15 satellites. Finally, yesterday, SpaceX launched yet more Starlink satellites from Cape Canaveral.
15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff of Starlink 435, go Falcon 9. Stage 1, chamber pressures are nominal.
And the landing.
And its next major activity will be the landing burn.
Stage 2 is the terminal guidance. Stage 1 landing burn.
Startup of just a single Merlin vacuum engine. We'll see landing leg deploy as well shortly. And also keep an ear out here for second stage engine
Stage
cutoff.
1 landing leg deploy. Seco. Stage 1 landing confirmed.
Now, looking further back into space history, last Thursday marked the 3rd anniversary of this show. The first SpaceWeek came out on September 22nd, 2019. Rather than a live show like this, it started out as a scripted, edited, and uploaded video. It was taking me up to 15 hours every Sunday to produce, however, so I burned out after 22 episodes. Then resurrected SpaceWeek as a live show. It still takes me a few hours to prepare, and I'm not always quite ready by showtime, as was evidenced by today's tardiness, but it's still much more manageable than it used to be. So, and I like the interactivity of the live format. Looking ahead to this week, tonight is a new moon. So if you have clear skies, look up. Tomorrow, Monday, September 26th, NASA's DART double asteroid redirection test will finally reach its destination. About 7 million miles, or 11.5 million kilometers away from Earth, is the asteroid Didymos. Didymos is about a half mile, or 780 meters, in diameter. Orbiting Didymos is a small asteroid moon called Dimorphos, only 525 feet, or 160 meters in diameter. NASA's DART mission launched back in November 2021 on a SpaceX Falcon 9 rocket. It took the spacecraft 9 months to reach its target. The DART impactor will crash into Dimorphos at high velocity tomorrow, after which NASA will measure the effect that the impact had on Dimorphos's orbit around Didymos. It's important to note that we haven't actually visually resolved these two asteroids as separate bodies. They're too small and too far away to see clearly, kind of like looking at binary star systems that are far away. In fact, the first time we see Dimorphos at all will be just a short time before the impact, as we receive images back from the spacecraft. But by carefully measuring the light reflected by the double asteroid system as Dimorphos passes in front of and behind Didymos, we can precisely measure the period of Dimorphos's orbit and thereby determine its mass. Same techniques that we use for detecting a lot of exoplanets, the dip in the brightness as objects pass in front of and behind each other. Still, we don't yet know the shape or composition of Dimorphos. Is it a loose pile of rubble like the asteroid Bennu, or is it a solid hunk of rock? Regardless of the composition, the impact is expected to affect its orbit by at least 1%. It's also important to note that this test will pose no danger to the Earth. Didymos is much more massive than little Dimorphos. The double asteroid system's orbit around the Sun will not be affected at all. Only the orbit of the smaller asteroid around its parent will be affected by the impact. Now, coverage of the DART impact will begin on September 26th at 5:30 p.m. Eastern, 21:30 UTC, with live views from the spacecraft. The main broadcast begins 30 minutes later. Then at 8 p.m. Eastern, midnight UTC, is the post-impact press briefing. I'll provide a live stream of the whole thing for you here on Raw Space. Also on Monday at 9:40 a.m. Eastern, 1340 UTC, a Long March 2D will launch the Yaogan 35 Group 6 satellites. No live stream is expected. Later on Monday at 7:50 p.m. Eastern, 2350 UTC, a different Long March 2D will launch an unspecified payload. Again, no live stream. Also on Monday, ABL Space was planning to launch their RS-1 rocket for the first time from the Pacific Spaceport Complex on Kodiak Island, Alaska. However, it looks as if they've been delayed until at least October 10th. The previous FAA TFR, the previous FAA TFR, or temporary flight restriction, that was set to expire on the 27th is no longer there on the FAA site, and it's been replaced with a new TFR from October 10th to the 18th. And I'll put a link to the TFRs in the chat so that you can actually go there and see for yourself. Just categorize it, filter it by the space operations category, and then you can see all the space-related TFRs in the country. There's been very little in the way of news about this ABL space launch, so we don't even know if there will be live coverage. We'll just have to wait and see, I guess. Rounding out Monday, Jupiter will make its closest approach to the Earth in almost 60 years. It will be at opposition, meaning it's on the opposite side of the Earth from the Sun. Because orbits are elliptical rather than perfectly circular, and thusly orbiting bodies travel at different speeds, the relative distances and timings of oppositions can vary. This time, Jupiter will be just 367 million miles, or 590 million kilometers, from Earth. It will be brighter and closer than many of us have ever seen it, though not by a huge margin, probably. Wednesday, September 28th at 9:35 a.m. Eastern, 1335 UTC, is the Expedition 6768 Change of Command ceremony. Oleg Artemayev will hand over command of the station to Samantha Cristoforetti. This is a quick broadcast, and I won't be providing a live stream, but you can check it out on NASA TV if you wish. They'll also replay the change of command during the following day's Soyuz MS-21 departure broadcast, which I'll get to in a moment. Speaking of, on Thursday, September 29th, ISS Expedition 67 cosmonauts Oleg Artemayev, Denis Matveyev, and Sergei Korsakov will return to Earth in their Soyuz MS-21 capsule. Undocking coverage begins at 3:15 a.m. Eastern, 07:15 UTC. Deorbit and landing coverage begins at 5:45 a.m. Eastern, 09:45 UTC, with a landing in Kazakhstan at 6:57 a.m. Eastern, 10:57 UTC. I will not be awake to stream this, so you can watch it on NASA TV. Just go to NASA's YouTube channel, or youtube.com/NASA. And again, I apologize. I used to cover every launch and landing, anything there was a live stream for, regardless of time, but doctor's orders, I have to better manage my sleep cycle, and so anything that happens in the middle of the night, I'm going to have to pass on. Unless it's Artemis, in which case I'll stay up for that. But an expedition crew return, I can skip on that one. But again, you can watch it on NASA TV. Also on Thursday at 8 p.m. Eastern, midnight UTC, SpaceX will launch another batch of Starlink satellites from Cape Canaveral. Live coverage will be here on Raw Space. At the exact same time, 8 p.m. Eastern on Thursday, midnight UTC on Friday, a Chinese Zhukua 2 rocket will launch an unspecified payload. No live coverage is expected for this Chinese launch. Then on Friday, September 30th, with a launch window from 3:01 to 5 o'clock a.m. Eastern Time, 07:01 to 0900 UTC, Firefly Alpha will be returning to flight after their previous flight's upper stage malfunction earlier this year. This launch has been delayed a few times due to unfavorable weather conditions out at Vandenberg, where the Delta IV Heavy just launched from. Again, since the launch is in the middle of the night my time, I will be asleep. But you can watch the launch live from the official source, which I presume will be Everyday Astronaut again, who is the launch coverage partner for Firefly. Also on Friday, with a launch window from 5:36 to 6:16 p.m. Eastern Time, 21:36 to 22:16 UTC, a ULA Atlas V will lift off from Cape Canaveral with the SES-20 and SES-21 geostationary communication satellites for SES of Luxembourg. This one I will have a live stream for. So that about wraps up the schedule for the coming week. As always, launch schedules are highly variable. Scrubs happen, delays happen, weather happens, and so keep your eye on the raw space calendar, if I spelled that right, which I put a link to in the chat. And also activate notifications, subscribe, of course, and activate notifications for the channel for any live streams that happen to pop up along the way. I want to take a moment to thank the stalwart channel supporters on Patreon, through the merch store and PayPal, who have continued to support the channel with their generous contributions, which help make this content possible, not only the live SpaceWeek episodes, but also the aggregation of restreamed launches and space events from around the world. Even if my face isn't on the screen, you can rest assured that my face is behind the screen, bringing you those launches. So thank you once again to channel supporters. And let me get to your questions. Let me see if we have questions. All right. Okay, looks like I'm going to have to scan through the chat for questions. It's okay, it is what it is. All right. So please bear with me as I scan for questions in the chat. And I should have mentioned up front to tag my name at Raw Space, but I was flustered and distracted by the doorbell that rang as I was beginning my stream. Starwalk at Raw Space. Hi. Hello, Starwalk. Mark Desire. H.G. Wells, referring to the Blue Origin New Shepard capsule. How do they come up with these rocket names? So I'm not sure what the inspiration for the capsule name of H.G. Wells was. H.G. Wells, of course, you know, literary science fiction giant of the past, but yeah, I'm not sure. Blue Origin doesn't say a lot about their inner workings, so I'm not sure where the inspiration for that was. And they're not consistent either. Like the NS3 capsule name is H.G. Wells, the RSS H.G. Wells, and the NS4 capsule name is First Step. So, I mean, they don't have a literary theme. They don't have whatever, but you know what? They can name things whatever they want. Mark Desire, escape system worked as it should work, which is exactly correct. Did exactly what it's supposed to do. Starwalk says, can we say that it was the New Shepard material exhaustion? So this capsule had flown multiple times before, I think 8 or 10 times something like that, maybe up to 14. I don't remember the exact number for this particular, the NS3 booster. Material exhaustion, maybe not. I mean, Falcon 9 boosters have been reused up to 14 times now, and are probably capable of multiple launches beyond that even. But I don't think that Blue Origin has come forward with their analysis or the results of their investigation as to exactly what the cause was. I haven't seen any announcements of that, and I don't expect that they probably will. They tend to keep things close to their chest. They're not terribly vocal about their processes and even the development of their highly anticipated systems, the BE-4 engine and the New Glenn rocket. Obviously, they have big facilities that have been, popping up in Florida and elsewhere. But yeah, it's kind of a black box. Blue Origin is. All right. Fred Jones says, yeah, Max Q is a thing. So the New Shepard mishap occurred right around Max Q. So there is a correlation there, but there may not be a causation. That remains to be seen by way of Blue Origin's internal investigation. I don't know if the critical failure in the engine or the whatever the apparatus around the engine, because it looked like the gout of flame was erupting from like the kind of the side next to the engine. But in any case, whatever the problem was, I don't know if it was Max Q related at all. It could have just been a coincidental timing, or it could have been. Again, that would be up to Blue Origin's investigation to determine. All right. Mark Desire, liquid hydrogen is, this is a question, is liquid hydrogen only being used on the SLS because Congress wants to reuse space shuttle technology? Well, I mean, SLS is largely a modernized reuse of old space shuttle technology. The first stage booster is essentially a redesigned space shuttle external fuel tank. The engines are literally space shuttle main engines, like that have flown on previous space shuttle flights. The solid rocket boosters are the same as the space shuttle solid rocket boosters, except they're 5 segments instead of 4. They're slightly longer for a longer burn time. But, and so by reusing the space shuttle main engines, they have to use the fuel that those engines were designed for, which is hydrogen. But although I thought I read somewhere that the engines are actually capable of burning other fuels, but I'm not a rocket surgeon myself. I'm not a rocket engineer. So I couldn't tell you if that's even a technical feasibility of using a different, kind of like using, refined vegetable oil in your car versus gasoline, but or in a diesel engine rather than diesel fuel. But in any case, I don't actually know if that's, I'm sure they weighed the pros and cons of like which engines to use, whether to use the space shuttle engines, whether to use a different kind of fuel. But obviously the fact that they're reusing the space shuttle engines is a huge component in the fact that SLS uses hydrogen, because those engines were designed to burn hydrogen. Let's see. Starwalk doesn't like the brown color of the rocket. It's more of an orange than brown, but I guess depending on the light, it can look brown. But yeah, the color of the SLS rocket is determined entirely by the foam insulation that is sprayed on the outside of the first stage, which is the same orange foam that was used on the Space Shuttle external fuel tank. And so, you know, I don't think they add dye to the foam. I think it just is the color that it is. Although I could be wrong, but I don't think they would particularly bother. Although didn't the original like SLS-1, the STS-1, didn't the original shuttle flights have a white external fuel tank? Maybe they painted it and then they decided to stop painting it. I forget that history, but in any case, if you have a problem with the orange, then you must have had a problem with the shuttle, which means you have a problem with me. But in any case, orange it is until the next rocket comes along. Mark Desire says it's amazing they still agree to launch Westerners in the Soyuz. That is interesting. I mean, given the saber rattling and brinksmanship that has happened. Although bear in mind that a lot of the fiery rhetoric from Roscosmos was purely coming from Dmitry Rogozin, who has since been ousted. Rogozin is no longer in charge of Roscosmos, and so it's possible that the Russian leadership decided that Rogozin was burning too many bridges and he needed to knock it off in the financial interest of Russia, because, like, for example, Roscosmos refused to launch, at the order of Dmitry Rogozin, refused to launch the OneWeb satellites that they were supposed to launch. OneWeb, of course, being a British managed, partially owned by the British government satellite constellation for, you know, similar to Starlink but on a smaller scale. They actually refused to launch it. The Soyuz was literally on the launch pad, and they they covered up all the international flags except for India, which Russia has close ties to, and they rolled the rocket back away from the pad and took all the OneWeb satellites off of it. And I don't think those satellites were ever repurposed to another rocket. I don't even know if the UK got them back. So I don't know whatever happened to those OneWeb satellites. But in any case, it is interesting that we're sending Americans up on Soyuzes again. Although for a couple of launches, it was just cosmonauts. Clomaki said, in the OWL launch, the Electron, last week, if you follow the path of the battery, the hot swap battery, after it's jettisoning from the rocket, you can actually see it explode as it hits atmosphere. It was awesome. That does sound pretty awesome. I didn't catch that myself. I tend to miss a lot of details because I'm like managing the stream and moderating the chat, so I actually miss out on some of the fun. But that is cool, and it's unique. No other rocket has that kind of hot swap battery jettisoning process. All right. Surf says there's tens of different videos about this, people with phones. That was posted while I was showing the Delta IV Heavy launch, so I imagine that's what he's talking about. Oop. Somebody said my studio looks great. Thank you. It's too bad you can't really see the details of all the stuff in the background, but maybe I'll do a tour of the knickknacks at some point. Oh, that was MVM Motovlog music. Thank you. I read the comment and then my screen like popped down to the bottom of the comments, and so I missed who actually said it. Okay, Wafakiri's telescope is broken. Rest in peace, telescope. Klomaki says, please let me know if China live streams their launches and where to find it. So typically the only Chinese launches that you can rely on a live stream of are ones from Wenchang Island in the far south of China, because that's a very public location on the beach and everybody can see it. Most of the other Chinese launch sites are far inland and they're much less public. They're like military facilities, they're remote. And the crew launches from Jiuquan in the northwest of China in the Gobi Desert. They typically live stream those. Sometimes there's a live stream from one of the other launch centers, but it's pretty rare. And I have not cracked the code of where to find these live streams. Like, you've got to track them down. You've got to know like the right Twitter users and the right websites to find where the heck these things are going to be streamed from, because it's definitely not low-hanging fruit. And honestly, it takes too much work to, like, I don't have time to track all that down. And so, if someone can provide me with that information, if I'm able to bring the stream to you, I will. But I can't be bothered to browse through Chinese websites trying to figure out where the heck the launches are going to be streamed from. Plus, dealing with the Chinese streaming services like Bilibili is a pain. But all right. Cheesy Princess says, if you find a sleep solution, please share it with me. Well, not streaming launches at 3 a.m. is a good start. So start with that. Surf says, what do you think about the spin launch? So spin launch was a system that a prototype was built for. The idea is that you spin a payload centrifugally at an incredible speed in a vacuum chamber and then release it directly from the ground through the atmosphere at like hypersonic speeds directly into an orbital trajectory. And I think that it's an interesting idea, but the incredible forces that are experienced by any payload in that system would preclude them from being able to launch any but the most, like the absolutely most hardened, solid state, like tanky satellites or very small satellites imaginable. And plus, air pressure is variable. Like, even though there's a reliable and consistent gradient of air pressure from the ground up to space, air pressure is still subject to weather. Like, you can have high pressure, you can have low pressure, you can have different pressures at different altitudes. You do have different pressures at different altitudes. You have wind blowing in different directions. You have the jet stream. And there's so much variability in the atmosphere that I don't see spin launch as actually being a viable solution to reach orbit, because all that atmospheric variability. Whereas with a rocket with its own propulsion, you can account, you can compensate for the atmospheric variability with gimbaling of the engine and whatnot, and firing it for different lengths of time or whatever. But still an interesting idea. If they are able to make it work, then that's pretty cool. But I doubt it. Not for an orbital launch. All right. MVM Motovlog Music, the space elevator. I've always been enamored with the idea of a space elevator. It's just so elegant. Like, you have an anchor sitting out there at geostationary orbit with a very, very long tether down to the ground, and you just ride the elevator up to space, and there you are. But the fact is that we don't have, our materials science is not to the point where we have anything with sufficient tensile strength to hold together at a length of, 23,000 miles. And so, yeah, at this point, we're not technically capable of building a space elevator, but maybe in the future we'll have, fancy nanomaterials that have incredible tensile strength, but we just don't have anything like that at this point. I mean, we have carbon nanotubes, but they're tiny. They're like millimeters. They're not, or even, I don't know, inches, but not miles, and certainly not tens of thousands of miles. But, all right, so I think that'll wrap it up for this week. Thank you all so much for joining me. Sorry for the rough start. And a lot going on this week, including some late night streams that I actually won't be able to bring you. But again, refer to the calendar, activate your notifications, and keep it raw. And until next time, take care. Bye for now.